Okay. Guys, we're going to get back into science. I know we've done some reading. Where is your science journal? All science journals. I'm seeing about 3 people without their journals on their desks. Okay, good. And I see those prepared. Excellent. Okay. Who can tell me what we have been, what unit of study we've started in science? Who can tell me? Yes.
Motion and design.
Motion and design. What is motion? What does that mean? Yes.
It has like forces. It's force.
What do you mean? Motion has force. What? Explain what you're talking about.
It has pushing and pulling.
Okay, that's a force. Okay. What does that have to do with motion? You're on the right track, buddy boy. Okay, yes. Good job, thank you.
Motion is a change of position.
Motion is a change of position, and to change a position, you need a what? A what, Jackson?
You need a force.
A force. Good job. And what can cause that force? I know we've made some vehicles and we've made them move. What causes that force? Isaiah?
Push and pull.
A push or a pull, okay. How do we provide that push or pull that gets our vehicle going? Ramon?
Like we can push it, and like say if this the vehicle, we can push it and it start rolling, and that's a.
So you can use your hand, your own force of your muscles. Good. How else can we get this to move? What's on your mind, Preston? Anything? No? Okay.
We can blow on it and it'll.
Okay. So what does that do? Good. We can wind and wind does what?
Push.
It pushes it. Good. Any other ideas?
You can touch it with your hand and start pushing it forward.
Okay. All right.
You can kick it.
Kick it. And what does that provide?
A kick provides movement.
It does provide movement. Is it a push or a pull?
Push.
A push. What's your idea, Drake?
Gravity.
Gravity. And what kind of force does gravity provide?
Sort of like a pushing, like a ramp or something. Could maybe.
Does it push or does it pull?
It kind of pushes it a little bit. It does a little bit of both, because at the beginning it pushes it down, but then after it pushes it close to the end of the ramp, it'll start pulling it down.
Okay, all right, good. Now, one thing I want us to think about, I'm going to use this vehicle here. Okay. Now, we have done some reading, and we have used some of our reading strategies, such as synthesizing. We got some new ideas, and tell me some things you found out from our reading that has to do with forces in this vehicle. Ramon.
At first, I thought with the vehicle, we can use it's just like a toy car. If you racing 2 toy cars, when you push them, they keep going until they hit something. When they hit it, it stops.
Okay, so a force provides the motion. It makes it go, right? Okay, whether it's a push or a pull, and then until another force, like you said, something has it stop or change position. Good job. Stop or changes position. Okay, good. What else did we learn from our reading this morning? What other new ideas or things that you understand did you get from your reading? Isabel?
I understood that because I thought like a force was just anything, but all it was a push and pull.
Okay. Now, I want you. Let's look at this vehicle right here. Okay, we've got everything on here. Let's look at this vehicle right here. It's not going anywhere. Are there forces acting on this vehicle? Because it's at rest. It's not moving. So is there force still here? Yes.
No.
No? Okay. Oh, somebody has a different idea.
Yes, because it's force that's still moving it, but it's not enough force to push it or pull it.
Okay. All right.
Still force.
There's still force there. Okay. What's your idea?
There's still force on it, but it's an equal amount of force.
An equal amount of force. What does that mean? So the equal amount of force, what?
It's keeping it from moving.
Okay, good. It's keeping it from moving. We've got gravity pulling on it. We've got this table in this book that's keeping it from going anywhere, and the force of the air. Everything is equalized. Come here, Allie. And when we have a balanced force, it's not going to move. It's going to be at rest. I want you to push as hard as you can. Okay? Are we moving? No? Well, I just moved my hand, but I mean, am I moving her hand? Is she moving mine? No, because we're pushing. We're going to push. Okay. Now, we have equal balance of force. She can't move my arm back, and I can't move her arm back because the forces are equal. Okay, now push as hard as you can. As far, okay. Now, the balance was unequal. She had more force on my arm. That unequal force forced my arm to move, which is what you were doing to the vehicles when you made them move. Thank you, sweetheart. What we're going to do today is we're going to test force on our vehicles. We are going to use what's called a falling weight system to do that. Okay? A falling weight system. Now, I want all eyes to follow me over here. Okay. You will have, would you get me my vehicle, please? Or whoever's vehicle. Okay. You see around the room, we have, thank you, sweetheart. We have placed our buckets and vehicles and some other equipment around the room. What I have is a piece of cardboard, and it has some fishing line and hooks, okay? You also have weights, okay? And we have a bookend, okay? And we're going to, why would we have a bookend to if we're trying to make our vehicle move? What's the bookend for? What do you think, Ethan?
Stop it.
To stop what? The vehicle? Yeah, okay. So it doesn't fall off the edge of our desk, of our table, of our bookcase. Now, I also want you to think about as we're doing this, you're going to take the hook and you're going to put it against the front axle. Remember that front axle is not moving. You're gonna hook it here, and you will have the other end right at the edge. Okay, what that means, I'm going to hold this up. Sit down. I'm going to hold this up. This should hang like this, where the top of this paper clip is just as equal, flush with the bookend. Okay? All right? Put your hand down, please. Now you're going to be putting weights. You have little washers, 25 little washers in a cup, and you have one large washer. In a few minutes, we're going to be reading our instructions as a team, but I just kind of wanted to show you how this worked. Someone's going to be holding our vehicle, while another one is putting on a certain number of washers, okay? Someone will be holding this, holding the vehicle. You're going to place the washers on the hook, and then one of you is going to say go, you're going to let go, and you're going to see how far it travels, okay? You're going, well, how do we know how far it travels? You will have also a tape measure, okay, in which you can travel a distance. You can use, make sure that you mark where the back tires are so that you know how far it goes. Put hands down, please, so that you know how far it goes. And then you're going to record in your journals, and I'll show you how to do this. You're going to record in your journals what you found. Then you're going to keep increasing the weights. I want you to think about it. If I have 4 small washers, Silva, and I put it on the hook, how is the effect of the motion on this vehicle going to be different than if I had 8 small washers? How's that going to be different, do you think? Or would it be different? Yes.
It would be different because the weight is kind of like helping the gravity stopping the vehicle and pulling it down. So if it has 4 weights, it'll go farther. But if it has more weights, it'll stop sooner.
Okay. So you think the more weight, it'll stop sooner, so it doesn't go as far. So the less weight, the further it goes. Who has another idea? Okay, I like your thinking. Yes.
The more weight it puts on the faster it's gonna hit something, because once you put the washers on there, the hook's gonna start moving down, and that's a part of gravity. It's gonna start moving down. Then our car is gonna start coming.
Okay, so what's going to happen? The more weight I put on there, how's that going to change the motion of the vehicle? The more weight, the more what?
The more faster it goes.
The more speed, the faster you think it'll go. Okay, well, we can see about who agrees with Jackson that the more weight, the faster and further the vehicle will go. Okay, so we have about 2, 3, 4, 5, 6, 7, about 10. Who agrees with Jaden that the more weight, the less it won't go as far? Okay, so we're going to see. We're going to find out. I would like you to open up your journals to page 13. At the bottom it says page 13. Open your journals to page 13. Okay. If you look on page 13, my camera's not working. If you look on page 13, who would like to read the first part of the directions? Because the first part we've already kind of have for us. Read the first part of the directions, Keely.
Pick up the materials. Place your vehicle on the long flat workspace assigned to your group by the teacher. Then set up the workspace just as it is pictured.
Okay, now if you notice the picture, what did you? The picture kind of looks like what I showed you, isn't it? Didn't it? Okay, the picture was just like I showed you. Now, you're going to read in your group the steps. Okay, 1, through pages 13 and 14. And I want you to talk about, you're going to read it through, and then I'm going to assign you to your spots, and you're going to follow these directions to complete the assignment. Now I want you to look on page 15 in your journal. Look on page 15 in your journal. Okay, this is your recording sheet. Page 15 in your journal is your recording sheet, and I want you to look carefully at this recording sheet. Now, if you notice the recording sheet, what is it? We're recording how our vehicle moves. And we have 3 columns. One column, it says number and size of washers. So it's giving you how many washers you're going to use and what size you're going to use. Okay? In the middle, you have a larger space. That's observations about how the vehicle moved. You're going to write down what you see. You're going to talk about it. Write it down. Each one of you will be writing it down, and one person from your group will be sharing out once we're finished. Okay? Now, I want you to look at this first one with one small washer, because you don't have to use one small washer. This is already showing it to you. It says, who would like to read what the 4th grade observer wrote in that area?
There was only a small force pulling the car. First, it wouldn't start moving. Then it moved very slow.
Okay, so that's one thing. If you find that it's not moving, okay, don't give it a push, but you can one finger touch the back axle and see if that helps. Okay? Okay? Just give it a touch. Don't push it, because you wouldn't get a true reading. Okay? So you're going to... Yes?
I have a question.
Yes.
As you set it up, like, you set it up just like it, but I don't know how do you, when you pull it back, how do you do it?
What do you mean when you pull it?
Like, how do you supposed to let it go? You pull it up?
You just let it, you put the washers on, you let it go and see if that'll pull the vehicle and see how far and how fast it'll go. We're going to see what it does to the motion.
So you pull it backwards?
No. The string, come here, Ramon. The string is pulled tight. Okay? Now, I don't have anything on here, so there's nothing pulling, really, this, okay, the vehicle, okay?
Let it go backwards?
So, no, someone's holding it. Once you put however many washers you're going to put on here, whatever it says, then you're going to let it go. And then you're going to see how far and how fast it will go with however many washers you put on there, whether it's 4, 8, 16, or 20. Okay? Okay? Then you're observing, you're watching, and you're recording what you're observing. You're going to do that with 2 small washers, 4 small washers, 8 small washers, 16 small washers, or if you don't want to use 16 small washers, you use 1 large washer. Okay? And each one of you has one of those. Once you have done your observations, then you're going to rank the speed. You're going to look and see which one was the slowest. And you're going to give it a number value of 1. Your next slowest is 2, on up to 5. What number is going to be your fastest? 5. So each one will have a different number from 1 to 5. Your slowest to your fastest. Okay? We're going to start with the reading of the instructions. Please turn back to page 13. Yes.
when we're doing the rankings,
Let's listen. It might be your question.
if it goes a certain speed and then half of that speed, like 1.5, can we like put 1 and then the fraction 1 and
Well, you're not going to rank them until you've looked at all of them, okay? Until you've done all the testing. And then it's only going to be 1, 2, 3, 4, 5, okay? You can state that 4 small washers went twice as fast or twice as slow as 2 small washers, okay? And that would be part of your observation. That's what you're writing down. That's an excellent question. Another question. No. Yes. No, you're fine. Uh-huh.
what happens if like the car falls because you put too many washes on it?
Well, then you just pick it back up, put it back up there. If the car falls, it falls. Okay, that's okay. All right. Sit down, and I'm going to give you a few minutes to read. You all can take turns reading instructions. And let's go. Each group, okay? No. I said you don't leave until this is done. Okay.